Good morning. Today we're going to take a look at transformations of logarithmic and exponential equations, both in terms of looking at an equation and describing the transformations and looking at a set of instructions and creating the equation. Let's go. Okay, so our first problem asks us to describe a set of transformations to go from f of x equals log of x to g of x equals 2 log negative x plus 6. So let's start just by naming the transformations we see, and then we'll figure out the right order to put them in. So the first thing we see is a 2 on the outside of the whole function. We know that when we see a number on the outside of the function, that is a vertical stretch or shrink. And because we see a 2 here and things applying to the vertical happen exactly the way we think they will, this is a vertical stretch of 2. Okay, now we look inside our parentheses, and that's where we find things that are applying to the horizontal. So if we're just looking left to right to start, the first thing we see is a negative applied to the x. That is going to be a horizontal flip or a flip across the y-axis, right? All of our positive x become negative x and our negative x become positive x. And then the final thing that we see here, again, it's within the parentheses, so that means it's happening to the horizon, to the x. We see a 6. And so in general, what happens on the horizon happens the opposite of how we expect it. So if this says plus 6, that means rather than going 6 to the right, we go 6 to the left. Now, we're going to have to check to see whether this order worked. Okay, so if we do it in this order, a vertical stretch of 2 means that our new function h of x should equal 2 times our f of x. And so in this case, that means it would be 2 log of x. Now, the flip across the y-axis means our new function j of x would be h of negative x. So we take our h of x, and that would be 2 log of negative x. Now, finally, our g of x should be our j of x and then 6 to the left. So that means plus 6. J of x plus 6. Now, when we go ahead and put x plus 6 into our j of x, that looks like this. 2 log negative x plus 6, which distributes out to be negative x minus 6, which is not where we wanted to land. So we have 2 ways to fix this. The first and easiest would be, instead of describing this as a horizontal shift to the left, which would be plus 6, we describe it as a horizontal shift to the right, which means we would do negative x minus 6, and when we distribute that through, we get the negative x plus 6 that we were looking for. So this is one way to describe the transformations to go from f of x equals log x to g of x equaling 2 log negative x plus 6. Now, the other way to do that would be to describe these 2 transformations in the opposite direction. So let's just take a quick look at that. So if after we do our vertical stretch of 2, we do a horizontal shift of 6 to the left next, that means our j of x will equal our h of x plus 6. So that means our 2 log of x plus 6. Now, when we flip across the y-axis, that means our g of x will equal our j of negative x. That means where we see an x, we substitute in negative x, and we have our 2 log negative x plus 6. All right, so order does matter here. So as you name your stuff, as you name your transformations, you need to go ahead and check and make sure that the order you're doing them in is going to result in the function transformation you're looking for. Okay, let's take a look at another one. So this time we've got an exponential. Describe the transformations from f of x being 5 to the x to g of x being negative 5 to the 1/2 x minus 3. Okay, again, let's list them, let's put them into effect, and let's make sure we've accurately described them. All right, so again, going from left to right, the first thing we see is outside of the x, right? It's applied to the y. Applied to the x is the stuff up here. Applied to the y is the stuff down here, or if there were anything down on this level. So we have a negative, so we have a flip. This time, our flip is being applied to the y. That means we are flipping across the x-axis. The next thing we see is we have a 1/2 attached to our x. Now again, what happens on the horizon is the opposite of how we think. So 1/2 feels like a shrink. It is a stretch. And then finally, we are moving -3. So again, what happens on the horizon is the opposite. -3 feels like it's moving to the left. This is a horizontal shift of 3 to the right. So now let's take a look equation-wise of how to make these happen and make sure that in this order, this is correct. So a flip across the x-axis means our new h of x is negative f of x. So that means -5 to the x. A horizontal stretch of 2 means our new j of x is h of 1/2 x. So everywhere where we see an x in our h of x, we replace it with 1/2 x. And now our horizontal shift of 3 to the right means our g of x wants to become j of x minus 3. So everywhere we see an x in our j, we're going to put in x minus 3. Is that the same thing? It is not. When we take our 1/2 and apply it to both terms, this does not give us 3. This gives us 3/2. The easy way to fix this is to reverse these two steps. A horizontal shift of 3 to the right next would make our j of x become h of x minus 3. That means everywhere there was an x, we substitute x minus 3, giving us -5 to the x minus 3. And then finally, our horizontal stretch of 1/2 means that our final g of x is j of 1/2 x. That means where we see an x, we substitute in a 1/2 x. And that's how we get g of x being -5 to the 1/2 x minus 3. Okay, so order matters, and you want to check your steps to make sure that doing those transformations in that order is in fact going to yield what you're looking for. Okay, let's take a look at one final one where instead of being given the equation, we're given the instructions and we have to make the equation. Okay, so our instructions say find g of x if g of x is a reflection across the y-axis followed by a translation 6 units to the right of f of x equaling ln x. Okay, so let's take a look at these instructions. The first thing we're doing is a reflection across the y-axis. That means our h of x wants to be our f of -x, right? Because reflecting across the y means we're altering our x. So that means the natural log of -x. And then a translation 6 units to the right means our g of x wants to be our h of x minus 6. And so when we do that, we get ln -x minus 6. And when we distribute that through, we get that our g of x, which is a reflection across the y-axis followed by a translation 6 units to the right, is ln -x plus 6, because that translation happened after the reflection. Okay, leave any questions in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.